di HQ lah Ibu Pejabat Kuala Lumpur.
That's why they experience forensic more than me. I expect that.
Boleh lah.
Okay, so part of the forensic experience more likely on the building ataupun untuk infrastructure such as highway.
Based pada building dan kerja civil. Cuma kalau
how
kita
about-
kalau melibat katakan slope ataupun apa tu melibatkan yang geotech ataupun cerun, kita tengok, lepas tu kita akan refer ke pihak berkenaan lah. Sama ada geotech ataupun kerja ni lah, cerun punya ni lah. Pasal kita ada forensik jugalah, forensik cerun dengan geotech punya dekat JKR.
Maybe we can share dengan classmate yang lain kan, kalau some part can get knowledge from your personal experience pun better lah, sebab my discourse lebih kepada case study from overseas kan. So let's say in Malaysia itself, macam mana the forensic work has been taken place and macam mana been conducted kan. Adakah few challenging constraints to full that supaya kita dapat lebih kurang macam oversee ke, on part of the assessment berbeza ke ataupun sama. Maybe I hope that Mr. Azuri can share your experience on part this matter lah. Okay, the next
Yelah,
one
can share lah.
Okay, next we call
Okay.
Mas Elina. Mas Elina dululah, boleh? Sekejap. Okay.
Okay, Assalamualaikum. Nama saya Mas Elina. Berasal dari Balustara tapi tinggal di Kulim lah. Sekarang bekerja di Hospital Bukit Mentajam sebagai juruteroperasi.
Operasi untuk berapa lama?
Operasi baru 2 tahun lah. Sebelum tu saya di bahagian lain lah. Di bahagian kesihatan awam. Sekarang ni di perubatan lah.
What makes you continue this master study?
Sebab sekarang ni saya berada di hospital. Jadi kita ni sekarang ni macam bangunan yang lama lah. Yang lama dah berusia 1 tahun. So banyaklah berlaku macam problem dari segi bangunan lah. Concrete spalling semua tu. So saya rasa macam nak belajar lah kan? Sebab kita pegang juga dari segi maintenance dan juga projek dekat hospital lah, projek naik taraf bangunan dan sistem lah.
Hopefully this course will benefit to you as well in your career.
Saya harap macam tu.
Okay. Thank you Puan Mas Elina. So next Encik Muhammad Imran.
Assalamualaikum.
Salam.
Terima kasih Muhammad Imran. Saya berasal daripada Perlis tapi dah lama saya menetap di Penang. Saya bertugas di Hospital Pulau Pinang lah sebagai jurutera operasi. Jadi tugas saya di sana banyak menjaga PSA lah. PSH, Perkhidmatan Sambungan Hospital dan juga projek-projek maintenance di dalam hospital lah.
So on part of the duty, Encik akan identify the problem kemudian hire consultant lah untuk buat ataupun kontraktor untuk buat repairing work. Betul tak? Ke macam mana tu?
Dia selalunya kalau kerja-kerja pembaikan ni memang di bawah maintenance dalam perkhidmatan sokongan hospital. Jadi biasanya kalau projek yang selain daripada PHH ni, dia adalah projek naik taraf lah. Kalau melibatkan reka bentuk, kita perlu melantik kontraktor perlu lantik PE lah untuk buat reka bentuk. Macam tu lah.
Directly dealing with this work lah kan?
Ya, betul.
All the best, good luck for this course and as well your career path. Okay, thank you Encik Muhammad Imran. The next one, Encik Muhammad Izwan.
Assalamualaikum dan selamat malam semua. Nama saya Muhammad Izwan Nudin bin Hamzah. Boleh panggil saya Muhammad Izwan. Bekerja sebagai jurutera perunding cahaya. Dalam industri lebih kurang 11 tahun. Sekarang ni saya punya skop more on design infrastructure dan juga involved dalam structure design for building, for factory and manufacture factory building, residential building, and also commercial building, and also deal with authority. Can say that my job scope starting from planning until CCC stage.
Panjang lah tu kan. Banyak
Yeah.
pengalaman lah. Dia punya area kerja tu kan banyak kena cover. Alright, so
Yeah.
hope this course can benefit to you as well in your careers path lah. Thank you Encik Muhammad
Doktor nak
Iswan.
tanya. Nak tanya. Untuk this study masters, is it suitable for become a lecturer one day?
Currently, if you are looking for lecturer positions, all public university require the candidates has a PhD. So,
Okay.
additionally, kalau you ada professional entitlement, contohnya IR ke, that will be more added value lah. So, be prepared for that one if you are having the intention to be a lecturer. So, we'll break 5 minutes sebelum kita continue study.
Okay.
Okay, now we started again dan saya nak panggil Cik Nur Hisham.
Okey, Assalamualaikum Doktor.
Salam.
Halo, dengar tak Doktor? Sorry saya pakai tab.
Ha?
Boleh
Okay
dengar,
je,
Doktor?
clear je.
Okey.
Clear.
Saya Nur Hisham Abdul Ghafur, menetap di Johor Bahru. Berkhidmat bersama JKR daerah JKR Johor selama 21 tahun. Antara kerja-kerja yang saya terlibat adalah kerja-kerja senggaraan bangunan, building maintenance selama 9 tahun. Projek infra, projek jalan selama lebih kurang 7-8 tahun dan sekarang saya berada dalam department road maintenance.
Pelbagai cabang area lah selama tempoh tersebut. So I think that
Ya,
you
betul.
are an expert industrial expert ni.
Tak adalah expert sangat Doktor, tapi insyaAllah lah boleh.
Every one of us are experts sebenarnya, because kalau tengok period of working more than 10 years tu, I can say that expert lah. Mungkin kita tak expert dalam specific area sebab kita dalam tempoh 10 tahun mungkin ada orang 2 tahun dekat satu department, kemudian dia ditugaskan ke department lain. Overall you have a lot of knowledge and experience. Itulah yang kita boleh simpulkan kebanyakannya lah anda semua. So saya rasa saya ajar di staff this time memang semua ni pakar-pakar ni. Pakar-pakar dah cukup lah sebenarnya. Okay, now we would like Tukar Nuha Afifah. Is there anything you would like to say, Mr. Nur Hisham?
Tak ada apa, tak apa.
Okay, thank you. So
Okay.
Nuha, Wan Nuha.
Ya, betul.
So
Saya Nuha daripada Perak. Sekarang bekerja sebagai jurutera awam di Perunding Azizi. Projek saya mostly cerun dan irrigation lah. Structure kurang sikit, tapi saya banyak treatment of the slope dan juga irrigation. Nak kata experience, saya baru setahun jagung. Last year saya baru grad. So itu
Okay.
saya.
Okay, currently slope treatment pakai kaedah apa?
Macam currently saya punya projek dekat Sungai Siput, area Kampung Bau. Kita ada 11 lokasi lah yang slope failure. So kita pakai very soft treatment sebenarnya. Ada yang soil nailing, ada yang pakai hydroseeding, ada yang pakai retaining wall, ada yang pakai
Hydroseeding
geogrid.
hydroseeding costly tak?
Kalau kita tengok yang BQ, dia taklah costly, dia a bit murah lah. That's why mostly kalau kita propose soil nailing dekat bahagian bawah slope lah. Dekat hydroseeding tu kita dekat bahagian atas slope yang kita banyak propose. So macam tu lah kalau kita punya design.
Then dia punya observation tu, dia punya period of part macam ni lah, you seed rumput kan, grass untuk bagi root strength, right? So how
Ya,
long it
betul.
takes to get the full strength?
Setakat ni kalau kita, sebab dia still in construction, kalau lah kita punya design, saya dengan ni lah, saya pun liaise dengan ada expert dengan seorang expert, so dia pun target for maintenance, kita boleh buat for every 10 years lah, hopefully, macam tu lah.
Interesting. So thank you for the explanations.
Okay.
And next is Miss Nur Farha. Sorry kalau saya panggil Miss ke Madam ke saya pun tak cuba kan. So I hope you all tak kisahlah. Okay, next is Nur Farha.
Assalamualaikum dan selamat malam. Saya Nurul Suraya. Saya baru habis belajar bulan 8 hari tu.
Okay,
Sekarang kerja. Ya doktor?
Kerja di mana?
Saya baru kerja sebagai site engineer di Pekciu Piling Company.
So far, is it tough for you?
Saya baru seminggu masuk. So setakat ni
seminggu
okey
masuk.
lah.
Okay. Alright. So I hope that you can stand along lah, along dekat situ, dekat company tu. Okay, thank you. Next is Nurul Hafizah.
Assalamualaikum Doktor, nama saya Nurul Hafizah binti Muhammad Rafiq. Saya berasal daripada Kuala Lumpur, sekarang ni saya tinggal di Pulau Pinang. Sebelum ni saya pernah bekerja di kontraktor buat piling e-compile dan saya juga pernah buat design selama 6 tahun. Buat bridge dan structure design. Sekarang saya bekerja di company kontraktor. Family sendiri punya lah.
Okay, bridge design tu dekat negeri mana?
Saya buat Central Spine Road dekat jalan yang package 5A, 5B, 5C. Basically package 5 lah, jalan daripada bridge daripada Bentong ke Rauk. Yang jalan,
Span dia berapa panjang dia?
Span dia berapa, 50 lebih jugalah doktor, tapi dia bukan satu span terus, dia bukan satu span terus, dia by package, dia ada pecah-pecah by package.
Berapa lama tu?
Saya buat design kat sana dalam 4 tahun, lepas tu saya pindah kat Penang, saya kerja konsultan juga tapi saya lebih kepada structure engineer. Yang masa saya dekat SMHB tu 4 tahun lah buat design bridge.
Good exposure lah sebenarnya design bridge tu, sebab tak ramai kan engineer yang direct dengan design bridge. Okay, thank you.
Terima kasih
Next
doktor.
is Nurul Hidayah.
Assalamualaikum Doktor.
Hello.
Nama saya Nurul Hidayah binti Abdul Basir. Saya bekerja di Majlis Perbandaran Sungai Petani sebagai penolong jurutera. Saya pengalaman saya taklah banyak sangat, cuma majlis ni dia buat pembaikan bangunan, jalan, longkang dan cerun. Cerun pun tak banyak tapi kita ada kes jugalah, 1-2.
Kes maksud awak tu macam mana tu? Kes heavy failure ke, worst failure ke?
Heavy failure tapi dia ada settlement sikit. Yang tu lah penyebab jugalah saya sama master.
Okay, sekejap
Yang tu je Doktor.
Okay, thank you for the explanation, Puan Nurul Hidayah. So next is Nurul Najwa, Cik ataupun Puan Nurul Najwa.
Assalamualaikum dan selamat malam. Saya Nurul Najwa Sari binti Ismail. Saya tinggal di Sungai Petani Kedah dan saya baru habis study dan sekarang bekerja di Jabatan Kesihatan Negeri Pulau Pinang sebagai penolong jurutera sivil.
Baru jugalah ni ya?
Baru.
Okay, welcome to the working world experience untuk anda yang barulah bekerja. Okay, thank you. Next is Syed Aiman.
Assalamualaikum, boleh dengar ke? Hello?
Very clear. Hello, very clear.
Hai. Okay, Assalamualaikum dan selamat malam. Saya Syed Aiman Farouk bin Syed Nasir, berasal daripada Shah Alam dan sekarang pun menetap di Shah Alam. Sekarang bekerja sebagai GPR engineer di X-Radar.
Apa tu?
Job scope saya primarily untuk map out and assess rebar structure dalam konkrit.
So, alright. I hope that you tak terkejut lah kalau discuss more on geotechnical sound ke, lack of structure ataupun lack of highway or pavement, etc. Alright, it's because we have planned, we have designed the structure. We have planned and designed the curriculum. So Okay, sorry for that one. That's weekend, right? So everyone is staying at home. So macam-macam lah sound ada. Okay, back to just now, Mr. Said Aiman. So you are in Shah Alam, right?
Ya betul.
Okay, so I think that from your experience, I hope that all of you tak terkejut lah kalau this content topic lebih banyak kepada explanations berkaitan dengan geotechnical ataupun some sedikit part of the highway atau lebih kepada tunneling or etc. Because if you look at to the lesson plan, all cases covered from overseas. So this kind of the benda yang kalau kita boleh reported all the local cases forensic dan kita documentedkan all these cases, much more easy for us to be as a reference in our life ataupun in our course study lah. But again, this is one example that you're going to learn throughout this course, yang mana cases tu a bit difficult lah because the location is not in Malaysia, kemudian dia punya problems not really related to us, but the approach, the process of forensics engineering tu are there. So proses yang terlibat semua adalah benda yang sama. Whenever you are doing the assessment in Malaysia ataupun overseas, we're going to take the same approach. So let me share to you our course content today. So I think that dalam learning activity tu saya dah attach one YouTube berkaitan dengan our case study untuk malam ni. So the case study description also will be given throughout this lecture sessions. So let me share to you, this one is our course outline lah ataupun topic for tonight. So this is on chapter 3, foundation failures. And the learning outcomes from this course or from this chapter to discuss the bearing capacity of foundations and the relation with settlement limits, and also to evaluate the failure cases using relevant theory to propose mitigation measures related to foundation failures. So saya rasa chapter 2 pun dia ada kaitan sikit dengan chapter 3. So saya harap lah, so you boleh sambung lah kata daripada chapter 1, chapter 2. So kalau ingat sikit, kita boleh masuk sikit lah chapter 3 ni, apa dia punya perkaitan ataupun sambungan dia punya penceritaan lah. So the contents of my lecture on part of the tonight is lebih kepada kita mula dengan theoretical background lah. For example, just giving you some idea kalau kata foundation ada berapa jenis, kemudian foundation tu apa fungsi dia dari segi design dan konsep, and then the bearing capacity, ultimate bearing capacity, the allowable bearing capacity, and settlement. Finally baru kita pergi kepada case study. So the case study will be in Canada, which was happened back in 1940s if I'm not mistaken. Yang tu pun saya akan cover kemudian lah. Okay, the next one is that the concept itself. Sebelum kita tahu macam mana bearing capacity failure tu boleh berlaku, we have to understand the structure itself. So dalam geomechanics ni, bila talking about infrastructure failure, the thing is that when we design a structure, foundations will be at the lower part of the structure. So foundation ni dia berfungsi untuk carry the load from superstructure and transmit to the soil beneath the structure. So if the soil is not strong enough, so you may have the consequences where the structure will fail. So we want to ensure that the soil will provide you a good ataupun strong bearing capacity. So by definitions, for example here, the foundations failure occurs when the applied load on the foundation exceed the soil capacity to support the load. Maknanya, your punya tanah tu dah tak boleh nak tanggung beban daripada atas, so dia akan fail. The failure ni kita boleh define from the shear strength versus dengan shear stress. So the concept, before you can understand further on part of the bearing capacity, we need to know some factors that contribute to the failures of this foundation ataupun failures to the soil. The first one is the shallow foundation. Actually, foundation ni can be categorized into two. The first one is the shallow foundation, and then the second one is the deep foundations. how we define or how we categorize this type of foundations according to the depth. If you have the depth of the structure or foundation here is more than 3 meter depth, so we need to use deep foundations. Kalau kata you are designed for simple structure which the depth is less than 3 meter, that is enough using the shallow foundations. So the shallow foundations are used to support structures that has relatively low vertical loads and are typically placed within the upper layers of the soil. So example of shallow foundations, for example, such as mat foundations, pad foundations, ataupun spread footing or any other part of the size itself tu, dia lebih kurang dari segi excavation depth, dia tak lebih pada 3 dan dia punya lebar pun you can measure easily lah. I mean that is very single structure. How about but in contrast to the soil itself, bila kita design, kalau you ada shallow foundation, you dah tahu shallow foundation apa yang nak pakai, sama ada pad ke ataupun mat foundations, we need to check pula the soil itself as a foundation. Soil ni kalau dia homogeneous or single layer, so kita tak akan ada much more problem lah part of the soil properties. Tapi kalau kata the penetration depth covered more than two layers of soil, maknanya dia lebih kepada single layer, or we call it as a multiple layers or stratified layers. So this will be influenced to the soil properties. I mean that dari segi unique weight of the soil, cohesion, angle of internal friction and also the density. So talking back to the soil itself, soil ni kalau kita pecahkan dari segi kategori, they can have a coarse grain and also the fine grains. Each of these soil group, they has different properties and characteristic. So kalau kata coarse grain, the strength will be rely on the internal frictions angle. In different to the fine grain, dia punya strength rely to the cohesion. So bila you ada combinations of the cohesive frictional soil, the strength will coming from the C and also the phi. C is the cohesion and phi is the internal friction angle. When you have the problem that dealing with the multiple layer soil, you can have the few properties involved. For example, one single layer will be not having same properties at the lower layer of soil. Maksudnya tanah dekat bahagian atas mungkin properties dia lain, as a properties A for example. And then lower layer from the upper layer soil carrying this different properties. So when this thing happen, you can see that the analysis not become easy. Dia melibatkan different properties, so we need to deal with the different analysis technique. Okay, the next one is that bearing capacity itself. So the bearing capacity, kalau ikut definitions, ability of the soil to support a load without causing excessive settlement or failure of the foundation. So it usually expressed in terms of pressure ataupun force per unit area, and it is denoted as Q. So the ultimate bearing capacity is the maximum pressure the soil can withstand without failing. So kalau kat sini kita ada dua Q, satu is the ultimate bearing capacity, QU ataupun ultimate bearing pressure or ultimate bearing capacity. Satu lagi kita panggil sebagai contact pressure or Q itself. So yang ni yang akan diterangkan selepas ni. Okay, the factor control to the bearing capacity, for example, soil type, depth of foundation, foundation size and shape, water table, and lastly is the overburden pressure. So what is the overburden pressure? Overburden pressure in the soil mechanics mostly kita akan consider as the unit weight of the soil multiply dengan depth. So kalau kata, for example, you want to estimate the pressure of the soil, let's say here, contohnya kalau kita ada single layer soil, this is as the ground surface, and then you are looking stress point 5 meter below from ground surface. For example, H ni sama dengan 5 meter. So the pressure, the vertical stress is sigma V sama dengan gamma times dengan H. Okay, this is my assumption. There is no water table effect. So kalau kata unit weight of soil ni kita andaikan dalam 18. So nak dapatkan overburden pressure ataupun vertical stress is 18 times dengan 5 meter. So that's the thing yang you akan dapat the value. So the pressure itself control or give the additional factor to the bearing capacity. For example, nanti you akan tengok how does this thing influence. I mean that kalau kita nak dapatkan ultimate bearing capacity, dia akan ada satu formula ataupun kita ambil teori Terzaghi. Dalam teori Terzaghi, dia ada few terms. Ada term 1, term 2 dan juga term 3. Term 2 tu di mana kita perlukan the vertical stress. How does the vertical stress give the final ultimate bearing capacity? So we want to check, is it bearing capacity safe or unsafe? How to check it? Kita kena dapatkan ratio antara ultimate bearing capacity bahagi dengan allowable bearing capacity. So the allowable also can be related to the factor of safety. So the next one is on example. Okay, this is the formula lah kalau kata kita nak dapatkan ultimate bearing capacity of the soil. This is what I mean. First, you akan ada first term daripada cohesion, second term daripada self weight of the soil, then third term is the density of the soil. So C gamma D, this one is the effective vertical stress, C is the cohesion, and then 0.5 gamma B and gamma is a term for number 3. So what is the NC, NQ and gamma? This one is the bearing capacity factors. So kalau you analyze for single layer, kita boleh ambil simple assumption menggunakan Terzaghi bearing capacity equation. But actually the formula ataupun the equation must be recheck sama ada kita nak analyze bearing capacity untuk clay ataupun untuk sand. So different soil properties will give you different formula ataupun teori calculation untuk dapatkan ultimate bearing capacity. Yang ni yang biasa dia guna untuk conventional calculation. Okay, kalau dia melibatkan foundations on multiple layer soil, so dia is more complex lah berbanding dengan single layer. So antara formula yang kita boleh guna, for example here is a Meyerhof and then the Hansen method ataupun finite element analysis. So finite element analysis adalah salah satu kaedah kalau kita ada numerical software, so yang tu lebih mudah lah untuk membantu calculate the bearing capacity. Tapi kalau you tak ada finite element analysis, if you have simple problems, you can do hand calculation ataupun menggunakan approximate solution. The next one is load distributions. So in the layered soil profiles, it is crucial to consider how the load applied by the foundation is distributed across the various soil layers. So different layers may have different bearing capacities and properties. So load distribution is a critical aspect of the design. So the load distribution ni, for example, additional loading that apply to the structure lah atau daripada foundation tu yang bertindak ke atas struktur foundation, asas kita. Okay, ini untuk layered soil and the last one is a bearing capacity failure. Bearing capacity failure pun dia ada beberapa jenis lah bearing capacity failure. Yang tu pun saya akan explain shortly lah untuk jelaskan beberapa jenis bearing capacity failure. Okay, mostly bila kita deal with the layered soil, somehow we need to do sampling and laboratory testing lah. Because bila you ada sampling and laboratory testing, so at least kita boleh tahu soil properties untuk setiap depth ataupun setiap layer soil. For example, this one is a layer 1 and here is a layer 2 and then here is a layer 3. So you ambil sampel dekat layer 1, mungkin dia punya gamma tak sama, C tak sama, V pun tak sama. Kemudian you buat testing lagi, you ambil sampling sampailah layer number 2, mungkin dia boleh bagi you different nilai C dan juga nilai V. So it says that kalau your foundations are laid on the layered soil, so it's better to have data ataupun lab results lah untuk carry out the calculations. So how to carry out the calculations or what are parameters rely to the calculation? For example here is the gamma, C dan juga V. So itu yang lebih penting lah. So soil properties daripada lab boleh bagi awak data ataupun input to calculate the bearing capacity. Okay, the next one is on
Doktor.
Yes.
Kita orang yang tadi slide tadi depan tu kita orang tak sama dengan slide kan nota kami.
Oh memang pun.
Oh,
Sebab
ya.
tak upload dalam YouFuture lagi. Nanti saya upload dalam YouFuture.
Okay.
Saya yang ni je kan yang sama kan?
Betul.
Okay, ini lebih kepada briefly idea how to differentiate the purpose or how to choose foundations. So as I said again, in order to choose the right foundation type, firstly kita akan tengoklah dia punya function dia, kemudian loading you berapa, and then the hard layer stratum you pada berapa kedalaman. Kemudian kalau you ada ball log report from the SI, so kita dah through the reading tu kita nampak okay hard stratum a bit low kan ataupun dia quite far, so kita dah tak boleh pakai shallow foundation, kita kena pakai deep foundations. So dia punya simple condition ataupun syarat dia, if the depth over B ratio less than 1 ataupun depth less than 3, so kita pakai shallow foundation. Tapi kalau dia tak memenuhi dua syarat ni, automatically kita boleh pakai deep foundation. But now we want to focus here on firstly bahagian shallow foundations lah. Okay, these are the factors need to be considered while you design shallow foundation. For example, the adequate depth, limiting settlement, and also the factor of safety. So adequate depth, for example here, the sufficient depth to prevent any adverse effect due to changes in surface condition, the climatic changes, and also the other temperature changes, or any kind of horizontal loads ataupun overturning moments. So the next is the limiting settlement, for example, total settlement, differential settlement, and the angular distortion need to be tolerated in the design. It also depends on the functional performance of the building and the requirement of the users as well as economic factors. So betul lah kalau kata you nak design deep foundation tapi you punya budget tu sikit, so kita tak boleh lah nak buat kan. So you have to design instead of deep foundation, mungkin kita boleh buat mat foundation kan, tengok keadaan kesesuaian. So next is the factor of safety. Factor of safety ni shear failures or shear failure occurs when the soil divides into separate blocks of stone which move fully or partially and tangentially with respect to each other. So this is the explanation, the derivation on the shear failure. In the part of the shear failure, we need to count also the factor of safety. So the FOS is the ratio of the shear strength of the soil to the maximum mobilized shear stress must not be less than the appropriate value. So for example, if the given design FOS 3, so you kena fulfill lah the condition. Kalau kata design you tak meet to the FOS 3, so you have redesign. Redesign meaning that you change the size ke, you change dimension ke, you change foundation type ke. So itu antara benda-benda yang you boleh adjust lah sebelum execute with the constructions. So I'm not sure lah how many consultants ataupun contractor or dah deal with the Eurocode 7. So kalau ikutkan, we also teach our undergraduate students design the foundation using the Eurocode 7. So kalau you can have some comparison between British Standard and Eurocode 7, you can see that they are different obviously lah. I mean that kalau Eurocode 7, every single thing part of the parameter, part of the design action ataupun design material tu semua you kena factorize ataupun bagi dengan factor of safety value. Okay, this is example limiting settlement. So kalau you buat foundation design, you have to ensure that the limiting settlement, maximum total settlement for sand is 40 mm. Kemudian maximum differential around 25 mm, and for the clay that is 8. Okay, next is on the modes of shear failure. Mode of shear failure, for example, general shear failure, local shear failure, dan juga punching shear failure. If I'm not mistaken, during undergraduate study untuk structure, selalunya kita akan design punching shear failure kan. Tapi some cases, dia mungkin hanya sekadar general shear failure saja. Dia tak pergi sampai punching shear failure. So that is the worsen failure can occur on foundations lah. Okay, untuk general shear failure, you can see the deformations when you apply the loads, the slip surface develop outward towards one of the both sides and eventually to the ground surface. And the failure is sudden, severe tilting leading to final collapse. And it is mostly associated with the dense sand or over-consolidated soils of low compressibility. For the local shear failure, so the shear plane starts from one side and ends within the soil. So the adjacent bulging may occur but little tilting. And the settlement which occurs will usually be the principal design criteria. And this type of failure normally occurs in loose cohesionless soil. And this is the punching shear failure and mostly occurred very loose cohesionless soil. So what is the loose cohesionless, kemudian very loose cohesionless ni dia merujuk kepada the size of the sand itself lah ataupun part of the sand density. Okay, these are some recommendation kalau kita nak design berapa nilai FOS yang dibenarkan lah. Kalau you ada some kind of the structure ataupun characteristic like this or the applications, so you can have 3 for example or 4. Okay, I'm not sure, mostly kalau kita buat analysis, we just take it 3 sahajalah. The essential points from this brief ataupun general overview about the foundations, most we can say the dense soil fail along well-defined slip planes resulting in a general shear failure. And then the loose soils do not fail suddenly and the slip planes are not well-defined, and so this is resulting in local shear failure. And the very loose soil can fail by punching shear failure, and the more settlement is expected in loose soils than in dense soils. Because kalau kita tengok dense soil ni is part of the meaning dia padat kan, so kalau kata nak adanya settlement tu dia agak kurang lah. Dan kalau kita tengok kalau soil tu can be categorized into the group according to size of the material, maknanya settlement pun samalah. Selalunya kalau coarse grain settlement yang kita boleh measure from the coarse grain ni, we call it as a immediate settlement. Kalau you ada fine grain soil, settlement dia can occur in the primary ataupun secondary settlement. So the expected failure surface for generation failure consists of rigid wedge of soil trap beneath the footing bordering radial shear zones under Rankine and passive zones. So Rankine is the teori yang dia guna untuk develop the shear failure plane. Okay, these are some definitions lah untuk foundation, contohnya ultimate bearing capacity. Yang ni pun saya dah mention tadilah dalam awal-awal. Ada setengah calculation tu dia nak net bearing pressure. So bergantunglah, kalau net bearing pressure ni is the ultimate bearing capacity tolak dengan overburden pressure. So factor of safety not to forget bila you deal with the foundation. And somehow we also have the presumed bearing value. So this is the preliminary design purpose. Okay, yang ni example lah macam mana you want to get the overburden pressure, kemudian how does this overburden pressure affected with the water table effect, part of the unit weight itself, and D is the penetration ataupun excavation depth to place footing on the soil. Okay, ini antara definition lain. Besides we calculate the ultimate bearing capacity, we also need to calculate the allowable bearing capacity. The allowable bearing capacity depending to the what limit state we are looking. Either we are looking for ultimate limit state ataupun we are looking for the service limit state. Kalau service limit state ni selalunya settlement punya condition lah. So kalau you nak calculate dia punya QA for immediate settlement, this is the formula. If you are calculating for consolidation or drain settlement, so this is the formula. But if you are only looking for the limit state value on part of the shear strength, so we can calculate the allowable bearing capacity using this formula only. So yang ni lebih mudah lah. So bergantung kepada what are you looking for. Are you looking for the allowable on both thing, limit state dan juga settlement aspect. So you have to calculate the Q allowable according to this formula. Okay, these are the assumptions made by Terzaghi because I have mentioned earlier pasal Terzaghi lah. So sebenarnya Terzaghi ni very conventional theory ataupun formula in the foundations. Whenever you have a textbook in geotechnical engineering, the first thing Terzaghi is very father known in soil mechanics. So they are very famous. Selain daripada Terzaghi, kita ada Meyerhoff, we have also Hansen. Why people like to use Terzaghi other than theory? Because the assumptions made by him, it's very easy lah. I mean that kalau you look at to here, the soil is a semi-infinite, homogeneous, isotropic, weightless and rigid plastic material. For example, kalau you have kind of problem in homogeneous and also an isotropic, there will be different assumption and also different analysis. So you dah tak boleh guna ultimate bearing capacity sama dengan QU bla 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 yang saya tunjuk tadi kan. So dia berbeza sikit lah. Homogeneous ni kalau kita kata the uniformity of the soil properties, that is so homogeneous. Isotropic ni part of the dimension ataupun the directions of the material in the same orientations. Tapi kalau kata and isotropic, so the orientations of the material dia tak sama, axis X ke axis Y ke dia tak sama. That's why people like to choose Terzaghi because the assumption itself is very easy to adopt and adapt in the analysis. And the embankment depth is not greater than the width of the footing. So we assume that the failure is a general. The failure zone, this is as looking at the back or at the bottom, that indicates the failure zone. So kalau you place a foundations on soil in the homogeneous, so this is the failure wedge that created in the zone 1, zone 2 and zone 3. So the failure angle is a 45 minus V/2. So you boleh nampak lah, because of it is assumed that it only generation failure, so you tak nampak lah the failure ni akan up to the surface of the soil. And maknanya bugging tak ada, tilting pun tak ada sebab dia assume sebagai generation failure. Kalau dia assume sebagai local dengan punching, so you akan nampak lah the bugging effect, tilting dan sebagainya. So the shear strength of the soil above the footing base is negligible. However, may have considered the shear above the footing base. So the soil above the footing base can be replaced by a surcharge stress. So this is the DF. DF ni actually is also can be included in the second term of Terzaghi formula, yang mana CU and C, example here, kalau kata kita nak calculate QU tadi, ultimate bearing capacity, QU ultimate sama dengan CNC plus dengan overburden pressure NQ plus dengan half. This is formula kalau I assume strict foundations lah. Kalau foundation kita circular ataupun rectangular, so formula ni dah tak boleh pakai lah. Okay, and gamma for example. Okay, mana datangnya NQ ataupun DF? DF duduk mana? DF duduk dalam NQ kat sini. Okay, sorry. NQ duduk kat sini akan ada DF. DF darab dengan unit weight. Darab dengan unit weight of soil, that is the overburden pressure ataupun effective V. So DF kat sini ni yang dimaksudkan sebagai surcharge stress. And the next assumption is that the base of footing is rough. Kalau you ada textbook, some textbook dia can consider also lah kalau you ada foundation smooth, so formula pun dah berubah dan juga berbeza lah. Okay, we want to touch sedikit lah berkaitan dengan definitions of settlement. Settlement ni sebab apa saya sentuh settlement, sebab tadi masa kita tengok calculation untuk factor of safety, you ada dua jenis, sama ada you nak calculate untuk ultimate state based on the shear strength ataupun you nak calculate ultimate limit state based on serviceability. Kalau you calculate for shear strength, maknanya the allowable bearing capacity tu kita boleh ambil simple calculations without consider the settlement effect lah. Tapi kalau you want to consider the settlement effect for primary lain formula dia, kemudian immediate settlement pun formula dia pun berbeza. So what is the settlement? Settlement is the vertical downward displacement at the base of foundation or other structure due to ground movement. What is the total settlement? Total settlement is the summation of immediate settlement plus dengan primary consolidation settlement plus dengan secondary settlement. So immediate settlement ni selalunya coarse grain, primary consolidation selalunya soft soil, clay, and then kalau secondary settlement ni melibatkan organic material. What are the causes of the settlement? Ataupun apa dia settlement tu is the cause of settlement is the reduction of volume air void ratio in the soil. So settlement ni dia is a resulted from the consolidation. So kalau you remember balik bila kita belajar soil mechanics, you akan dengar compaction, you akan dengar consolidation. So compaction dengan consolidation, they are different thing. Consolidation biasanya reductions in volume with the expulsions of the water. Maknanya kita nak kurangkan air, kita buat consolidation process. Tapi kalau you nak kurangkan void of the material, kita gunakan compactions. So daripada consolidation ni dia akan memberi kesan dia adalah settlement lah. Dia akan ada perubahan dari segi vertical displacement. Initially sebelum you buat consolidation mungkin tinggi dia 10 meter, tapi lepas you dah consolidate, you dah the water flow out from the soil volume, from the soil layer, kemudian volume pun dah berubah. So you akan nampak lah the final settlement pun ataupun the final height berkurangan. So that is resulted to the settlement. So when we plot the graph, this is the graph that you may have from the odometer test. For example, the graph pun bergantung lah sama ada you plot on the Taylor method ataupun Casagrande method. So on the initially is the immediate settlement. Kemudian the middle sections here from the 0 to 100% is the primary consolidation settlement. Toward after that is the secondary consolidation settlement. Selalunya secondary consolidation settlement it takes time untuk betul-betul stable lah ataupun dia dah reach to the final stage. Okay, these are the type of foundation settlement. Kemudian causes dia, kalau you ada uniform settlement, apa contoh dia? Kalau you ada differential settlement, or what are the significant or anything that you can see obviously, and what are the factors? For example, kalau due to the direct causes, it may have due to the weight of the building, life load ataupun dead load. Kalau indirect causes, for example, here is the earthquake, failure of collapsible soil underground infiltrations, and then failure of underground tunnels and mines. So these are the causes for indirectly that causing to the settlement. Okay, these are some explanation untuk immediate settlement, primary settlement dan juga secondary settlement. I hope that after having this kind of explanation, you dah boleh jawab lah learning activity for week 6 if I'm not mistaken lah. So kalau kita tengok immediate settlement, sometimes it also can call as a short-term settlement. It can place in coarse grain soils at high permeability and in unsaturated fine grain soil of low permeability. Occurs over a short period of time, which about 7 days, for example. So it ends during construction time. For primary settlement, it also called as a primary consolidation. It takes around 1 to 5 years, for example. And then the primary settlement frequently occurs in saturated inorganic fine grain soil and expulsions of water from pores of saturated fine grain soils in the course of primary settlement. For secondary settlement, is the consolidation of soil under constant effective stress, frequently occurs in organic fine grain soil and continues over the lifespan of foundation structure similar to creep in concrete. Okay, the next one is on, okay, these are the theory involved. Kalau you want to calculate the settlement, for example, ataupun settlement from site or settlement from the lab. Settlement dalam lab ni for sure kita kena ada data odometer test lah. Kalau you ada some budget, you boleh buat lah plate bearing test, pilot test, SPT, CPT dan juga probe test. Okay, apa beza plate bearing test dan juga pilot test? Agak-agak daripada pengalaman lah, saya rasa these are very common. We can hear from our industrial experience, right? Ataupun daripada past study or your knowledge. I mean that you dah biasa dengar kan. Okay, apa beza plate bearing test dan juga pilot test?
Pilot test kita untuk test pile, untuk test pile. Plate bearing test yang kita nak, plate bearing test bukan kita nak test apa, kita gunakan plate untuk kita nak check, kita nak test dia punya bearing capacity untuk soil.
Betul. Application dia kat mana? Kalau kata foundation tu, foundation jenis apa?
Footing lah, kita nak check sama ada footing, normal footing boleh apply for that area ataupun tak lah.
Bopal
Saya
Dr.
setuju jawapan.
Bopal.
Okay, saya setuju dengan jawapan daripada Encik Muhammad Izzuan, betul. Kalau let's say lah we just want to use footing saja kan, kita buat plate bearing test pun okay lah sebab kita nak check bearing capacity dia. Tapi kalau you plan okay lah kita tak nak pakai shallow foundation, kita nak pakai deep foundation, tapi kita nak check bearing capacity soil kan, so kita ambil lah pilot test.
Pilot
Part of
test.
the budget, I think that lebih mahal lah kan pilot test. Pilot test ni pula ada yang jenis static, ada yang jenis dynamic kan. Bergantunglah pada your punya budget. Okay, selain daripada tu kita ada SPT, CPT. CPT ni is a cone penetration test. And then the other one is a JKR and Macintosh Prop. Okay, yang ni some theoretical lah untuk calculate the settlement. And this is example plate bearing test. Plate bearing test ni something that as Mr. Izwan mentioned just now for shallow foundations, and then we want to see dia punya bearing capacity underneath the structure, and kemudian you kena tengok lah dia punya contact pressure, and the final thing yang kita nak tahu tu apa yang selalu you measure adalah bearing capacity versus dengan settlement lah. For example kat sini vertical axis tu is the plate bearing, and then horizontal axis is the settlement lah. Settlement kalau selalunya design kita set as a 25 mm lah. You tengok lah settlement tu reach or more ataupun less kan. So yang ni pun I think that ada bukanlah very common, saya rasa you can have from the online and any sources regarding the plate bearing test. Okay, the other last part here untuk empirical plate bearing test sebab ada setengah settlement tu kita tak calculate from the lab, so we want to calculate from the data side. So ini antara contoh correlation or formula yang boleh membantu awak dapatkan answer for plate bearing test settlement calculation. Same goes kalau you ada different soil type. Kalau sand, ini contohnya formula dia lah. Okay, we want to go in depth for this topic chapter 3 lah. Sebelum kita pergi ke case study yang transkena tu, the first one is to understand the process of forensic investigations. The first is begin with the preliminary assessment. Preliminary assessment ni, I think that we get the informations part of the desk study punya work lah. Kita collect informations berkaitan dengan our sites, kemudian failure tu berlaku kat mana, apa puncanya. Ini semua yang very commonly we started. And then we do the geotechnical investigation. Do we need the soil sampling? And then kita perlu tak buat testing because we want to investigate what are the causes to the failure. Adakah contohnya kalau slope failure, ada tak they have pre-existing slip failure before this? Kalau tanah tu memang dah pernah ada history slope failure, so dia tak mustahil lah kalau failure tu berlaku lagi. Contohnya previously dah pernah berlaku slope failure, kemudian kita tambah je kejadian lama tu tutup dengan tanah baru. So next year tiba-tiba berlaku balik slope failure. So bila kita buat soil testing, kita dah nampak dah ada plane, ada orientation failure plane. So that's the indicator kenapa some case failure kita perlukan soil sampling because we want to study the past history of the soil. Kalau kata past history of the soil tu tak perlu buat soil testing, so we need to get the data from any other consultant or any other relevant or public authority yang pegang that report lah. Tapi biasanya orang akan buat testing jugalah. The next process is a structural assessment. Kalau dia melibatkan bearing capacity failure, so we want to check, is it the bearing capacity failure is only due to settlement? Lepas tu nak tengok pula settlement tu betul ke disebabkan oleh soil movement, atau mungkin juga failure tu berlaku disebabkan oleh tilting of the building. Building tu dia dah bagi sign dah, indicate dah, dia dah tak apa kata, dia dah ada sedikit some inclination, kemudian the building starting to have surface failure. So we have to do the detailed investigation, for example non-destructive test ke ataupun destructive test. Basically kalau existing building ni kita akan conduct NDT test lah. NDT test ni kita akan tengok concrete strength, kemudian reinforcement strength dia lepas dah berlaku failure lah. The next one is a load analysis, kemudian interview and documentation review, finding element analysis, root cause analysis, expert report, and expert report, and lastly is a legal and liability consideration. So ini yang very detail sebenarnya, biasanya dia akan ambil yang secara general lah sebab bergantung kepada kesesuaian dan juga budget. Okay, yang ni antara konten untuk kelas malam ni. So sebenarnya bila every case study yang cover dalam this course, dia akan ada few important sections lah. The first one is a case description. Next one is a relevant theory. followed by mechanical analysis, and then mitigation measures, and lastly is a lesson learned. So kalau nampak yang paling tough for me, content dekat number 2 dengan number 3 lah, sebab as I told you earlier, this part of the geotechnical lah, dia lebih kepada geotechnical theory and sound. Kalau kata macam some words tu kita tak familiar, they a bit difficult lah, sebab the calculation analysis need the informations. What is the overburden pressure, what is the contact pressure, what is the vertical stress, and etc. Somehow they can use different words, different but bring the same meaning. So benda-benda tu lah yang take it confused for some students lah untuk memahami the concept itself. So the reference for this case study from the Buzrin 2010s. So wait a second.
Okay, seterusnya.
Alright, okay, next is on the first learning outcomes, similar as I explained earlier. So just back to definitions again, bearing capacity failure is a failure defined as a foundation failure that occurs when the shear stresses in the soil exceed the shear strength of the soil. So how does it mean? So kalau kata kita nak explain, this is the shear stress at failure, and if you have for example clay saja, so kita boleh kata the shear stress is equal to the shear strength. For example here, sekejap. Tau F sama dengan tau S sama dengan C tangent phi plus dengan sigma n. So the formula here depending to the soil type lah. Kalau kita andaikan this is our shear stress and this is the shear strength. By definition also, dia relates to the what we call it a more column failure criterion. So kalau this one is our failure line, so the failure or the shear stress is defined here. So that's why I say kalau kita ada different types soil, dia akan bagi different shear stress and also the shear strength. So if the shear stress exceed the shear strength, maknanya failure can occur lah. Soil dah tak boleh tanggung lagi beban daripada atas dia. So the depending of the strength is coming from the C for example dan juga phi. So back to the soil properties lah. Kalau kata shear stress you tak exceed daripada shear strength and bila kita plot more circle for example, dia tak reach or dia tak touch to the failure line here. So you can say that the foundations or the soil is safe. Tapi kalau kata the failure has already touched and you can define the failure line, so the shear stress already reached to the shear strength. So this is resulted to the bearing capacity failure. So we go to the case descriptions. Again for this chapter 3, kita ambil one case for shallow foundations and another one case untuk pile foundations. Untuk shallow foundations, we are referring to the transconal grain elevator. So this is case reported back in 1913 in Canada. It is purposely to build ataupun it has a warehouse designed to store grain from the city of Winnipeg and the wider area. So the purpose of elevator was to provide relief of the Winnipeg yards during the months of peak grain shipments. And it is catered to carry around So the building has engine room, kemudian green storage area containing 5 rows of 13 containers with a total volume of 30,000 meter cube. So maknanya bangunan ni besar lah, lebih sebab dia gudang kan, gudang yang nak letak beberapa functions kat sini. Kemudian the construction is based on reinforcement concrete slab measuring 23.5 meter times dengan 59.5 with an upper and lower reinforcement concrete slab 60 centimeter thick between which there is a space for emptying. So such foundation structure with 2 slab and transverse and longitudinal stiffness wall is in very rigid foundations. So looking to these explanations is actually the building as shown in the figure A, and this is the picture showing the conditions of the warehouse. So nampak dia punya storage ada few row vertical structure. Kemudian dia punya foundations is around 59.5 times dengan 23.5. So kalau tengok sini is a shallow foundations lah sebab dia menggunakan large foundations to carry the functions of the building lah. So this is the conditions before collapse. Now we want to investigate the causes to the failure and how did the assessment were carried out. So the excavations, just the explanation macam mana proses pembinaan, kira kata dia buat balik penyiasatan lah, dia buka balik buku penyiasatan, dia siasat balik macam mana history of the construction, and then dia relate balik finding from the case failure ataupun from the site failure, and then they found out during the time masa dia nak buat constructions 1911 tu, dia buat case tu ataupun excavation untuk elevator foundation ni at around 1.5 meter dengan foundation soil tu adalah soft soil. So the excavation penetrated into relatively stiff blue clay, which is typically for that area and locally known as the blue gumbo. So ini yang dia nak explain soil profile dekat kawasan gudang tersebut. So maksudnya kejadian tu berlaku, failure tu berlaku 1913. So penceritaan dia patah balik 2 tahun sebelum failure tu berlaku pada masa construction. So dia dapati kawasan tu adalah tanah jenis lembut lah dan stiff blue clay, and there is no boring profile. It was reported by White 1953 lah, and the excavation reached its design depth of 3.7 meter. And the field bearing capacity tests were carried out by loading a plate laid upon a prepared smooth clay surface. Maknanya untuk these functions, dia dah buat juga dah plate bearing test. Tapi mungkin some profile not direct to the answers lah. I mean that mungkin kalau dia buat detail soil profiling dengan dapatkan boring test, so lagi baguslah untuk explain the soil profile actually has ataupun underneath the foundation is a soft soil. So bila soft soil maknanya the way we want to construct, dia dah tak boleh construct as what are the soils behave lah. And the test loading was applied using a specifically constructed wooden framework. So this test indicates that the soil was capable of bearing a uniformly distributed load of at least 400 kPa. Because the maximum foundation pressure was not supposed to exceed 300 kPa. So this is what they found. So the test appeared to satisfy the requirements of the engineer. So bila dia buat testing, they found out that dia tak melebihi daripada syarat. So they thought it was fine and it was okay. But somehow they dah misjudgment and misconclusions lah. So they assumed that the blue gumbo at the site had similar characteristic and the depth to that on which similar rough foundations of many heavy structures had been founded in the vicinity of Winnipeg. Since there is no boring, kemudian dia sendiri pun tak conduct soil testing ataupun site investigation testing, they just rely SI report from other vicinity area that constructed close to the case failure. So they assume soil profile pun sama. So that's why lah dia ambil simple conclusion. So dia tak buat soil boring testing sebab ada dah bangunan sebelum-sebelum tu buat heavy structure safe kan, for example lah. So that dia dah just rely for the previous lepas SI report dan dia pun buat construction without knowing that there's a danger below the structure. So you want to assume that the steel blue gumbo clay at the site had similar characteristic and depth as the site of other complex building built in the surrounding area. So some say that bila you buat that study, that's the thing lah yang kita boleh mulakan. Contohnya kita dapatkan report-report daripada public authority ataupun dekat kawasan yang kita nak buat construction tu, potential construction site tu, dah ada bangunan sebelah kita. So kita pun boleh tanyalah Riki kan dia punya SI report dulu. So, kita boleh get the idea, but the truth is that about our site tu dengan cara you buatlah site investigation. Walaupun site investigation tu agak mahal tetapi dia boleh menjamin soil profile untuk site area awak tu macam mana lah. Contoh dekat sini dia tak buat SI tapi dia rely on the other buildings yang near to the warehouse. So itu pun antara benda yang mungkin zaman tu lah kan dia make simple assumptions lah kan. Kalau ikut dia sebenarnya kena buat proper site investigations. Okay, the blue gumbo ni kalau ikutkan soft clay ni it's very sensitive. I mean that part of the high water content and it is very low permeability. So bila kita deal with the soil like this sebelum kita nak buat construction selalunya orang akan buat treatment lah ataupun kita buat consolidations. The purpose we are doing consolidation because we want to expel water through the site area, and from the consolidation sebenarnya dia increase the vertical stress. So dia bagi satu tambahan lah untuk profile tanah tersebut. Tapi this case bila dia tak buat yang sepatutnya, so that's the thing yang berlaku lah. Okay, what are the failures occur? The failures occur from this one, it is large settlements of the storage building were noticed after the tanks were filled with the grain up to 87.5. Initially, dia tak nampak langsung settlement tu berlaku. Tapi bila dia dah, because tujuan dia buat gudang ni sebab dia adalah macam transit area. Dia nak pindahkan hasil pertanian tu dalam gudang tu. So bila dia dah fill up the storage tu, barulah dia perasan bangunan tu sebenarnya dah tak vertically, dia dah starting to tilt ataupun incline. So within 1 hour, the settlement increased to 300 mm with a slope to the west, and within 24 hours, the foundation soil collapsed and the structure tilt about 27 degrees. So this is very historic failure occur in Canada. But it's become something good lah sebab we learn from the mistake, and again from here, geotechnical area becomes something interesting to figure. Okay, what are the problems actually? The several deeper exploration boreholes were drilled after the accident.
Doktor muted kot? Doktor? Doktor Mashita?
I'm back. Yes, I'm back.
Oh, okay.
Sorry, just now. Okay, for okay, benda dah failure dah berlaku, jadi dia buat penyiasatan. So CSI lah, crime scene investigations, dan bila dia dapati lepas dia buat investigation, barulah dia buat exploration menggunakan borehole yang sepatutnya dia buat pada awal-awal peringkat sebelum construction bermula. So the sample were taken to lab. The sample taken were not laboratory tested. However, soil classification was conducted using optical observations. So there were no further explanation kenapa dia hanya menggunakan optical observation instead of doing the lab test. So dia dah buat exploration tapi dia tak buat lab test. Commonly kalau you direct deal with the geotechnical punya construction activity, bila kita dah buat SI, selalunya kita akan ambil sampel tu kita akan ambil different type of sample lah, ada yang undisturbed, ada yang disturbed. Kemudian kita akan bawa ke lab. that commonly practice. So bila kita buat lab testing, kita akan dapatlah physical characteristic of soil. Contohnya unit weight soil tu berapa, density dia berapa, moisture content dia berapa. Kenapa kita perlu buat benda ni? It's just like we are doing detailing about the soil profile. Contohlah kan, macam kita nak kenal orang yang kita kena look at the physical characteristic of the human. Look at the eye itself. Kemudian kita tengok dia punya physical face dia. We look at the body. So the same to the soil. So bila kita dah dapat physical characteristic, then we need to go details testing carry out with the mechanical testing properties. Antara properties yang kita boleh dapat daripada mechanical testing such as shear strength. Dalam shear strength ni contohnya cohesion, internal friction angle, kemudian kita akan ada coefficients of the odometer test. So these are very important mechanical parameters that may give influence in the design stage. For example, macam tadilah kalau you nak calculate ataupun analyze ultimate bearing capacity, benda yang perlu ada adalah shear strength of the soil. Kalau you design untuk foundation on clay, so kita perlukan cohesion. Kalau you design foundation on sand, kita perlukan internal friction angle. If you are not doing this testing, mechanical testing for example, how do you know that the strength of the soil? Macam mana kita nak define bearing capacity failure tu shear stress exceed ke not exceed daripada shear strength? Betul tak? So kalau kata dia just buat determinations on physical dan juga mechanical testing, just doing the optical observation, that is not enough. Optical observation for example, kalau dia buat soil testing in few meter depth, dia akan nampaklah different coloured layer of soil that indicates soil color only lah. So color tu dia tak boleh bagi detail explanation lebih kepada properties characteristic ataupun mechanical characteristic. Whatever it is, they should be come together dengan data from lab lah. Semua ada physical ataupun mechanical. So in this time, it was concluded the soil was a uniform layer of clay which confirmed the previous design assumptions, and that was also the geological structure of the wider area. Maknanya bila dia ambil optical observation, they assume that tanah tu adalah homogeneous. Maybe they look at, okay lah, tanah clay kan, mostly colour lebih kurang sama, coklat ataupun coklat light ataupun dark chocolate. So assume that way as a uniform. So bila uniform layer, the part of the strength, so we can see uniform jugalah. Kalau kata tanah tu ada 3 different layer, indicates 3 different color of soil. With a difference, some ada light chocolate, kemudian dark chocolate. So bila dia assume sebagai homogeneous as a single one, so we can say the soil strength C lebih kurang sama lah daripada atas, upper layer, middle layer and lower layer. That's the assumption. But actually, they not occur that way because bila kita analyse, kita boleh analyse as a single ataupun kita boleh analyse as a multiple layer. Kalau you analyse as a single, so we can say that the C is uniform throughout the layer soil. But if you assume it is multiple layer, so the C may not constant ataupun similar. So in 1951, the failure already was few years ahead. Then they came to engineers untuk buat detailed explanation and detailed investigations on that failure type. So they conducted borehole testing and then collect the undisturbed soil samples and conducted triaxial tests, and the results shown this way. So it is very unexpected. Maknanya mungkinlah pada tahun bila dia buat optical observation, dia punya limitation adalah equipment ataupun dia tak ada expert yang ramai untuk further investigate. But then in 1950 something, coming these 2 engineer, dia dah ada better knowledge and dah ada hands skill, then dia buat site exploration, they found out these are the soil profile. Maknanya dekat kawasan tu, ini sebenarnya yang memberi gambaran tanah dekat kawasan tersebut. There are different type. For example, from 10 meter to 20 meters. So its color is clay, silicon-side, laminated small, and then deeper to 10 meter. So the color pun dah berubah. And the final one they made to the hard stratum. So bila dia buat details part on the mechanical testing by using the unconfined compressive strength, it found that every single depth of the soil profile shows different strength. So you akan nampak lah, kalau dia start from the 10 meter, dia punya strength 108 kPa. And then it's a fluctuate at the middle depth below the 10 meter. So dia tak constant sebenarnya apa yang dia assume at the firstly kan. So below 7.5 meter, you akan nampak lah the reading of the unconfined strength actually it's not as a 108. It can be less than 100. Kemudian when it's go deeper, surprisingly the strength lower. That's supposedly unexpected lah. Sepatutnya bila, if you remember when you study on part of the geological formations, bila kita pergi makin dalam ni sebenarnya kita dah meet to the hard stratum lah. Kemudian bila kita relate sebalik dengan weathering grade of rock from the level 1 until to the level 6, maknanya dekat bahagian atas permukaan tanah tu adalah weathered rock. Weathered rock form to the soil. So you pergi ke grade 1 tu is very barren rock ataupun intact rock. So memang dia punya strength tu high compared to weathered rock ataupun soil. So bila dapat reading macam ni, yang mana sepatutnya jauh daripada permukaan tanah, sepatutnya strength tu tinggi, tapi ini yang berlaku sebaliknya. So it shows that from the reading, the color, grain distribution and mineralogical content the clay may have looked almost homogeneous with the depth from wash boring. So it is what they assume ataupun what they found from the soil exploration. The compressive strength in the upper layers of clay was 108, and then the undrained shear strength, QU is the compressive strength. So kalau nak dapatkan undrained shear strength, so kita kena bahagi dua lah. So the undrained shear strength is 54 kPa, and the clay in the lower layer was of lower strength parameters, which is 31 kPa. So these findings suggest that the elevator failure was mostly caused by the insufficient bearing capacity of its foundations. So the conditions of constructions, the load under the foundation structure and the geological structure of the transcontinental grain elevator were similar to those of the surrounding buildings in the wider area. However, this structure had a much wider foundation, and thus the impact of the load on the foundation soil was much deeper. So instead of assuming having the same structure as other buildings, so sebenarnya dia lupa bangunan tu ada different part of criteria daripada structure dia, yang mana size footing dia lebih besar, kemudian dia punya function pun berbeza, dan the soil itself also different. Okay, just to relate, how does the building shape give impact to the bearing capacity of the soil? For example, here, as I told earlier, there are some factors control to the bearing capacity of the soil. One of it is the foundation type and size. For example, if we have these two different foundations, the left side is a square, for example, and the right side is a circular foundations. Talking about the contact pressure, if these two foundations having different sizes, for example, the contact pressure also different. You can see that what is the contact pressure? The contact pressure is the surface area that connected or that contact to the soil. So the contact area untuk square foundations ni lebih besar lah berbanding contact area daripada footing yang bentuk circular. So the contact pressure ni dia akan memberi impact to the bearing capacity ataupun the bearing pressure. Maknanya dia punya distribution tu lagi besar lah. Kalau you ada contact pressure yang bentuk circular footing ni, contact pressure dia kecil. So stress distribution pun kecil. Dia tak boleh pergi beyond that depth lah. Kalau you ada square ataupun pad foundation, so the contact pressure tu pun berbeza. So what is the contact pressure ataupun contact stress? Is the stress or force distribution exerted on the soil by a loaded object or foundations. So it is a critical concept in geotechnical engineering as it helps determine whether the soil can support the load without experiencing excessive deformation or failure. So the contact pressure depends on the load magnitude, shape and distribution as well as the properties underlying the soil. How does it affect to the foundations. Contohnya load distribution, soil properties, contact area, stress distribution. So yang saya mention tadi tu contact area, stress distribution ni kita boleh tengok selepas ni lah. Ni contohnya kalau different footing, different size, different shape, so the contact pressure pun berbeza lah. Maknanya kalau you pergi makin dalam, contact pressure dia tu makin meluas lah, makin besar lebar dia. So kalau you ada this kind of the circular footing, dia pun berbeza ikut lebar. So kalau you punya size kecil ni, contact pressure dia only this one sajalah. Tapi kalau the contact pressure can extend ataupun decrease by the depth, for example, depending to the loads as well. Okay, the failure mechanism. Okay, last but not least, before we end our class, on part of the failure mechanism, because we have studied the constructions and then some explanations on the technical aspect, dan kita nak tengok dia punya failure mechanism lah. An excessive settlement takes place due to consolidation and secondary compression and is caused by a decrease of the soil volume below the foundations. Therefore, it takes place rather slowly and the ground surface around the structures subside together with the foundations as shown in the figure 4.4a. So this is the problems. We have the foundations and we have the settlement that resulted from the loads applied as a S. B is the where dia punya apa ni, bila you tambah lagi loading tu daripada initially 10 kilonewton for example, kemudian you increase loads until one time the source cannot support any more loading applied, so you can see that the failure starting to occur. So this part of the bugging created. In a bearing capacity failure, a failure mechanism is formed below the foundations, so the settlement takes place much faster and without decrease of the soil volume. Therefore, the displacement soil has to find itself and exit, causing a ground heave in vicinity of the structure. So this ground heave is a distinct feature of the failure of transconal grain elevator. So they represented by sketch the image of failure mechanism as shown, similar to what we have seen from B and also from the C. So apa yang berlaku pada transconal grain elevator ni, ini yang digambarkan melalui figure 4.4b. It is occur when the loads increase to 87% and during the short time 1 hour, so dia dah nampak berlakunya settlement below the foundations and silting that created next to the foundations. So ini antara failure mechanism for that of the problem. For foundations, as I explained earlier, kalau ikutkan dia ada generation failure, dia ada local shear failure, they also can has a punching shear failure. But this time, maybe it's not generation failure, but it can be a local shear failure. So because bila local shear failure ni, dia berlaku untuk tanah jenis clay, kemudian dia punya indicator dia adalah tilting ataupun the bugging vicinity of the structure. Because here pun dia dah highlight yang mana causing a ground heave in the vicinity, causing heave in the vicinity of the structure. That's the sign ataupun failure mechanism to the building. So the particular problem of transconal grain elevator was that the failure mechanism of the plate loading test were apparently confined to the upper stiffer clay layer due to the relatively small size of the plate. The elevator foundations, however, developed a much deeper failure mechanism which entered the weaker clay layer significantly reduced the bearing capacity. It says that the plate bearing test yang dia conducted masa construction tu, pada awal-awal peringkat constructions tu, dia not enough ataupun bearing capacity yang resulted from the plate bearing test, dia tak pergi sehingga bawah. Dia just limit to the few meter. So it's assumed that it's already enough. But then bila dia construct, baru dia nampak sebenarnya plate bearing test tu tak bagi cukup jawapan untuk estimate the bearing capacity of the soil. He found that sebenarnya bila dia pergi bawah, baru dia tahu tanah tu lebih rendah, part of the weak clay soil. part of the strength tu sebenarnya lagi rendah berbanding dekat bahagian atas. So dia assume bila dia dah jumpa kat atas ni part of the design condition dia dah meet, yang mana 300 kPa, yang di set tu 400, kemudian dia tengok strength soil pun dah cukup. Tapi kalau kata the plate bearing test exceed the size of the plate bearing test, dia punya contact pressure pun akan lebih besar, so they can predict below the first layer of clay, so they can go deeper lah. So when they did some experimental further ataupun investigation, it found that dia sebenarnya failure to not occur in the first layer saja, they can occur below that the layers of soil. So it's actually covered multiple layer failures lah. It's not on the single layer soil. So after this, you will see that how the analysis will carry out for single layer and also for the multi-layer. So the analysis were done by the researchers, where they did on the study, they analyzed back to understand what was happened during the time, and the analysis will carry out to compare mana sebenarnya approach yang lebih bagus lah, ataupun they can make comparison at the time of 1953, kemudian before that 1911, kemudian in the present day, how they do the analysis further to understand the case study of the transconal grain elevator. Okay, any questions before we end our lecture tonight? So this part of the transconal grain elevator focus on the foundation failure, shallow foundation failure. Untuk yang contoh kedua tu dia akan lebih fokus kepada pile foundations lah. So yang ni kita tak pergi kepada content analysis lagi, mechanical analysis, kita baru pergi ke case description, failure mechanism. So I think that there's some other sources lah untuk lebih memahami selain daripada tengok reference or textbook yang saya upload dalam YouFuture. You also can watch from YouTube yang mana dia ada some short explanation lah kepada this kind of case study problem. Okay, any part of the technical term ataupun words yang you unfamiliar or you want to have further explanations before we end our lecture tonight? Okay, I think that
It's okay,
ada
Doktor.
apa?
Nanti kami study dulu.
Okay.
Nanti in case tak faham nanti kami akan roger Doktor balik lah.
Boleh, tak ada masalah.
Sebab geotek, bagi saya geotek ni agak complicated lah. Even though benda ni basic. Sebab saya dah lama tak practice. Geotek dia susah sikit. Nak fahamkan dia punya teori tu boleh lah, tapi nak fahamkan dia punya konsep ni sometimes yang susah sikit lah.
Analysis dia.
Analysis tu.
You were not the first one said the same thing. Okay, so saya rasa assignment satu you berkaitan dengan, tak tahu lah berkaitan dengan bearing capacity failure ke apa. Tapi dah boleh start tengok lah. Kan? Dah boleh start tengok. Okay. Okay. Have a nice weekend, everyone, and I see you after midterm break in week 7, face to face on Saturday.
Okay, Doktor.
Thank you and assalamualaikum.
Waalaikumsalam.
Thank you, Doktor.
Okay, terima kasih, Doktor.
Terima kasih, Doktor. Assalamualaikum.